This is an Algebra 1 class, and we're going to graph quadratic functions using symmetry. We've already talked about how to find the line of symmetry for a quadratic function and how to find the vertex. When a quadratic function is in standard form, y equals ax squared plus bx plus c, the line of symmetry is found by using x is equal to the opposite of b divided by 2a. Then we use that value for x to go into our equation to find the y-coordinate for our vertex. So let's go ahead and start by finding the line of symmetry and the vertex of the graph. Then we'll see how to graph it using symmetry. So the first thing that we need to do is finding the line of symmetry. We identify that a is equal to 3 and b is equal to -6. So using our rule, x equals the opposite of b divided by 2a, I get x is equal to the opposite of -6, which becomes +6, over 2 times 3, or 6 divided by 6, which is equal to 1. I'm going to use that value for x to find the x and y coordinates of our vertex. Our x coordinate is going to be 1, and we're going to substitute 1 in for x in our equation. So we get y equals 3 times 1 squared minus 6 times 1 plus 2. Evaluating this, we get 3 minus 6 plus 2, which is equal to -1. So our coordinates of our vertex, x coordinate 1, y coordinate of -1. Now we also are able to tell whether this vertex is going to be the maximum or highest point on the graph or the minimum lowest point on the graph. We tell that by looking at the value of a. Since 3 is a positive number, it's greater than 0, I know my graph is going to open upwards, so that vertex is going to be a minimum value. Now to get points on this graph, we're going to choose 2 points to the left of the line of symmetry. So if x equals 1 is our line of symmetry, 2 points to the left, that is smaller, would be 0 and -1. Plugging 0 into our equation, we get y equals 3 times 0 squared minus 6 times 0 plus 2. Well, that gives us 0 minus 0 plus 2, or a y-coordinate of 2. Substituting -1 in for x into our equation, we get y equals 3 times -1 squared minus 6 times -1 plus 2. And simplifying that, we end up with 3 plus 6 plus 2, which is 11. Now we're ready to graph. I waited to graph so that we could see what kind of values we get for x and y, and notice y is going all the way up to 11. So I'm going to take my x-axis and put it down towards the bottom of the graph. I need to go up to 11 on our value, and maybe move our y-axis just a little bit to the left. I'm going to start by dotting in the line of symmetry. The line of symmetry is not actually part of the graph, but it helps us to guide to get the graph. So I'm going to dot in the line of symmetry x equals 1. And on that line of symmetry, of course, we have our point that is our vertex. We have the point 1, -1. Now I'm going to graph the 2 points that we found that are to the left of the line of symmetry. We have 0, 2, and we have -1, 11. Now, since this is symmetric, it's a U-shaped graph, to get our other points, we simply reflect the points across the line of symmetry. So from here, it's 1 unit from the line of symmetry. We're going to reflect it over and get a point on the other side. We're going to do the same thing up here. It's 2 steps away from the line of symmetry, so go over 2 to the other side, and we have both sides of our parabola. Connecting them in a smooth curve, we have our graph. Okay? And that's our graph of our parabola. Let's do that again. We have a second example, y equals negative x squared plus 8x minus 7. Again, to find our line of symmetry, we need to find our value of a, which is negative 1, and our b, which is 8. So our line of symmetry, using the rule x equals the opposite of b divided by 2a, we get x equals negative 8 over 2 times negative 1, or negative 8 divided by negative 2, which is 4. This is our line of symmetry. To find the vertex, I use that x equal to 4, and I put it back into our equation to find our y-coordinate of our vertex, because a vertex is always on the line of symmetry. So we get y equals the negative of 4 squared plus 8 times 4 minus 7. So that gives us negative 16 plus 32 minus 7, and that is equal to 9. So our vertex is the ordered pair 4, 9. Now, again, we want to find out is our vertex a maximum or a minimum. This time our value for a is negative. Our negative 1 is less than 0. So our graph is going to open downwards. So our vertex will be a maximum value. Now I need to choose 2 points on the left side of the vertex. You can also choose the right side, but if we always choose the x, we're always doing the same thing. So it's easier to remember. So 2 points to the left of 4, x would be 3 and 2. And then we're going to substitute those values for x into our equation. So we get y equals the negative of 3 squared plus 8 times 3 minus 7. So y is negative 9 plus 24 minus 7, and that is equal to 8. So we have 3, 8. And now substituting 2 in, we have y equals the negative of 2 squared plus 8 times 2 minus 7. So y is equal to negative 4 plus 16 minus 7, and that is equal to 5. Notice our y values again are all the way up to 8 and 5. So again, I'm going to need a little bit of room up towards the top of the graph. So I'm going to have my x-axis again towards the bottom of my grid. And my line of symmetry is all the way over at 4. So I'm going to move everything over so that I have 4 more in the center of the graph. Here's 1, 2, 3, 4. And again, I'm going to start by dotting in the line of symmetry at x equals to 4. Our vertex is always on the line of symmetry. It's the ordered pair 4, 9. So here's our vertex. I'm going to graph the 2 points that we found. We have 3, 8. And then 2, 5. And then I'm going to reflect those over the line of symmetry to get the other side of the graph. So 1 step over the line of symmetry, 2 steps over the line of symmetry. We get our U-shaped graph, this time opening down. So it's our point 3, 8 and our point 2, 5. So we have points on our parabola. And that's how we graph a quadratic function in standard form using vertex and the line of symmetry.